Hello everyone, how are you all doing today? In this video, let's try to integrate this trigonometric function. In order to integrate this trigonometric function, if you notice there is sine as well as cosine in the denominator. In order to integrate this, there are a couple of methods. Method number one is the moment you convert this function in terms of tan or tangent, something magical will happen and you can just simply do U-substitution and we'll be able to integrate. Let's see how do you do that method. So in the denominator, we already have sine x plus cos x and there is a whole square. Now, if you want to convert it to tan, what you have to do is you have to multiply and divide by cosine in the denominator. So I'll divide by cosine and then I'll multiply by a cosine, and don't forget that there is already a whole square in the denominator. So essentially what I'm doing is inside of that whole square, I'm just multiplying and dividing a cosine. And why I'm doing that? I'm doing that in order to convert that function in terms of sine and cos to tangent or tan. Now, in order to generate a tan term, what you do is you split that cos in both of those terms. You give that cos to this sine and this cos over here. And let's see what do we get. So we have integral of 1 divided by, okay, here when you give this cos to this sine, so the sine over cos will become tan. So you have tan x plus this cosine x divided by cosine x will become 1, okay, and you have multiply by, so you have this whole thing getting multiplied with cosine x and there is a square here, don't forget that, and you are integrating with respect to x. So you see that you are able to generate that tangent term in the denominator. Now what you do is you give that square to both of those terms in the product form, okay. So you have integration of 1 divided by tan x plus 1 the whole square times cosine square x, and you are integrating with respect to x. Now if you notice carefully, we know that differentiation of tan x, we know if you take derivative of tan x, it is nothing but sec square x. If derivative of tan x is sec square x, if we think about putting the tan x or even tan x plus 1, that function is equal to u, the differentiation of tan x, which is sec square x, should be present in this integral. If you notice carefully, this 1 over cosine square x is nothing but sec square x. Okay, so that means the differentiation of this function is already present over here. Now let's write that down to make it obvious. So we have integral of, we have 1 over cosine square x is nothing but sec square x, and in the denominator we have tan x plus 1 the whole square, and we are obviously integrating with respect to x. Now let's put that denominator function tan x plus 1 is equal to u. So let's say we put that tan x plus 1 is equal to u. And why do we do that? Because we already see the differentiation of that function present in the numerator. Differentiate both the sides with respect to x. Differentiation of tan x is sec square x and differentiation of 1 is anyway 0. So you can write sec square x dx is equal to du. Now let's convert that entire integral from the x world to the u world. So you have integral of that sec square x dx can be just written as du over here. So you have du divided by, and that tan x plus 1 is nothing but u. So you can write u square. Now this is nothing but u to the integral of u to the power minus 2 du. By the law of exponents, you can just write 1 over u square as u to the power minus 2. And we can just apply the basic power rule of integral and write that as u to the power minus 2 plus 1 divided by minus 2 plus 1. Let's add the constant of integration c. I hope that makes sense. We know we can convert it back to the x world. We know u is nothing but tan x plus 1. So you can write it as tan x plus 1, and minus 2 plus 1 is minus 1 divided by minus 1 plus constant of integration. See, and this is really your final result. You can clean it up a little bit. We know this to the power minus 1 can be written in reciprocal, and this minus can be written in the numerator. So we have minus 1 over tan x plus 1 and plus constant of integration c, and this is nothing but the clean final result of the integral that we wanted to solve. How simple that integral became when you converted that function which was in terms of sine and cos to tangent and just put that tangent function is equal to u. I hope that made sense. If you want to see more such calculus videos and want to master calculus and math in general, hit that subscribe button today. I do post math and calculus content every single day. If you don't want to miss it, hit that subscribe button. I'll see you tomorrow.